Hello everyone, welcome to Techie Talks AI. Today we are tackling something exciting and honestly a little frustrating about modern AI tools. Have you ever wanted a ChatGPT-like app that you can run on your own machine without shelling out for subscriptions or API keys? Or maybe you are curious about how these AI chatbots work under the hood, but feel overwhelmed by the complexity? Well, I have been there too. That's why I'm building a fully open source chat app with Streamlit and Ollama, all in a container environment. It's a complete solution which is free, transparent and scaled down so you can understand every step. Whether you are a developer or just an AI enthusiast, stick around. I'll show you how to set it up step by step and test it live. So here is the plan. We'll create a simple web-based chat interface using Streamlit, and we'll connect it to Ollama, which is an open source tool for running large language models locally, and we'll package everything in Docker for easy setup. By the end, you will have your own private customizable AI chatbot running on your machine. Before we dive in, you will need Docker installed on your system and basic familiarity with Python and the terminal. I'll share the link to the Git repository with all the code that I'm using in this video in the description, so you can follow along. So let's get started. First, we'll write a Streamlit app in Python. So this is our app.py. So first of all, this is the folder that we have. So this v1 folder inside this LocalGPT is what we'll be using, and there are 3 files inside. So one is this app.py, then we have Docker file, and we have requirements.txt. So these are the 3 files that we'll be having as part of our code. Okay, so now this app.py, this is the Streamlit application file. So this is super simple. So here what we are doing is we are writing the code so that the front end can be managed by Streamlit, and it will talk to the Ollama model that we'll be setting up. So with the help of this Ollama, Streamlit will be able to get LLM access. So we import Streamlit and Ollama, set up a basic chat interface and connect to a local LLM. That is what we are doing. So here, this is where we are importing the libraries. So there are 2 libraries required, which are Streamlit and Ollama. And here we are initializing the Ollama client. So this is where the Streamlit will get access to the Ollama client that we will be running locally. How we can set this Ollama client, I will be explaining when I explain the Docker file, because we will be containerizing that as well. Okay, now next we are just making some beautification for our front end UI. So this is just adding the title and some subtitle for our front end chat application. And now check this out. We use session state to store the chat history, and then we'll also stream responses in real time. So here, this particular section, we are initializing one array, which is the messages array. So this is where we'll be storing the chat history. So this chat history we'll be using in order to display the chat history. See this one? So we are displaying the chat history based on whatever values, whatever messages that we store within this session state. Okay, and this message will contain 2 items. One will be the role and also the content. So it will have the role and it will also have the content. So that is why we are using those. Now next we have the prompt. So here, see this one, this is the user prompt. So there will be a text box where user will be able to enter their prompt, and that prompt will be displayed within the chat history or chat list. And finally, here we have the actual working of our chat application. So this is used to stream responses from the LLM model real time. And here you can see this particular section is where Streamlit is calling the Ollama model. In this case it is the Llama 3 model, in order to get response for the user query. And here it is giving the input as the user prompt. See, the user prompt is given as input with role as user, and here you will also see the stream option as true, so that the answer will be streamed, like each word will be streamed one after another. And then finally what we are doing is we are appending, or we are storing the response from the LLM model to our session state messages storage, so that it will be properly displayed within the chat history. So it is a very simple Streamlit application with very small UI elements. Next, we containerize it with Docker. So here is the Docker file that we are using. So the idea is we are creating a Docker file which will contain everything, like it will contain the Python environment where Streamlit will be running. It will contain Ollama where the model will be running, etc. So let's see the Docker file and see what it is doing. So in this Docker file, it installs Ollama. It will pull a model like Llama 3 and also sets up Streamlit. So everything open source and runs locally. So let's go through this particular Docker file. So here we are specifying the parent image. We are using Python as a parent image. Then we are setting the working directory for that Python environment, which is /app. And then we are installing some dependencies for this to work. And next thing is, see here we are installing Ollama. So within the container, when the container runs itself, it will have Ollama running. So we don't need any external Ollama or any external model or external LLM required. Okay, and after installing Ollama, what we are doing is we are pre-downloading or pre-pulling, or we are pulling the model during the build itself. So we are doing this because if you don't do this, every time you perform the Docker run operation, it will be pulling the Llama 3 image, and this Llama 3 image is around 4.7 GB in size. So each and every time you run a new container, it will be downloading that much data. So that is not optimal, right? Especially when it comes to a local environment where you will be doing a lot of experiments. You may have to run multiple containers from the same image, etc. So there you don't want this duplication of download happening. So in order to prevent that, we are using this pre-installed model. So we are adding this particular line to perform that operation. Okay, so what it will do is it will be downloading Ollama, it will be running Ollama, then it will be waiting for 5 seconds, then it will perform the pull operation with Llama 3 model, and then finally it will kill that particular process. So here, in order for this pkill to work, it will require this pro CPU. So that is why this package is defined in here. Okay, so now next is the requirements. So here we are copying the requirements.txt from the current directory to the working directory, which is /app, and then it is installing the packages, Python packages based on the requirements.txt file. So this requirements.txt file, it is actually a package manager. So here we are configuring it to install two packages. One is Streamlit and another one is Ollama. So you will be able to specify the version of those things as well in here. So here, in order for us to be able to import the Streamlit and Ollama Python libraries, we want it to be installed. So that is why we are adding it in the requirements.txt file, and in the Docker file we are executing or installing the requirements based on that requirements.txt file. And now we are copying the application code, the main code, which is our app.py. We are copying to the work directory, which is /app, and then we are exposing the port. So we are saying that this particular container will have Streamlit, which will be listening to port 8501. So that port we are specifying. And finally we have the CMD. So CMD is the command prompt. So it is the command that will be executed when the container starts. So here it is a combination of multiple commands. So here it will be performing the Ollama related items. So here these are Ollama. So it will run Ollama. It will pull the Llama 3 model, and after that it will run the Streamlit application. It will run the app.py with Streamlit command line interface, and then here we are specifying for Streamlit the server port, which is 8501, and also we are specifying the server address. So this means localhost. So these are the files that we have. So app.py, which will be used to run the Streamlit application. Then we have the Docker file, which will set up everything within a containerized environment, and requirements.txt, which will contain the package list which Python will need to have for Streamlit to work. Now let's build and run it. In order to build, let's go to our terminal. First we need to cd into the proper directory. So let me just cd into LocalGPT, and inside that we have to cd into the v1 folder. So that is the current path. So as you can see, inside LocalGPT, v1 is the folder that we are working on. So now we are going to build the Docker image. So we will just build and run the Docker image. So first let's perform the build operation using the docker build command. So docker build, I'll use the tag as localgpt-demo dot or demo colon v1, and then I'll be specifying the build context using dot. So let's perform this build. So this build will take some time because it will be installing a lot of items like Ollama, then Python, etc. But in my case, since I already built it, it is using the cache. So first time when you perform the build operation, it will take some time because it has to download around 4.7 or 5 GB of data. So it will take some time for it to be ready. But for me, since I already built it earlier, it is using the data from the cache. Now that we built this image, let's go ahead and run the container. So that is the final step. So we'll use the docker run command. So docker run -p, then we'll use the port as 8501 itself, and then we'll use the image name, which is in our case localgpt-demo colon v1. So let's go ahead and run this. So now our application is running. So now our chat app is live in the browser. So in order to access this application, now what I have to do is I have to go to my browser. I'll browse localhost colon 8501. So this, if I browse, I'll be able to access the application. So now this is our local GPT application that is running within our local environment. Now watch this. I'll ask it a question like, say, what is the capital of France? So now first time it will take some time because it will initialize the model, and after that we will be getting the response immediately. See this one, the capital of France is Paris. See this response now it is coming from our local LLM. It is not using any online ChatGPT or online account or anything. It is just coming from the local LLM that is running inside our container itself. Now let's try something harder. Like let me just ask it to explain say quantum physics in very simple terms. So let's see what it comes up with. Okay, so here it is explaining in brief about quantum physics. So it is telling us the difference between classic physics and quantum world. Okay, now it is telling us about the rule changes in quantum physics compared to classic physics. Good. Okay, see all this information it is providing based on its knowledge, its trained knowledge, and here it is giving us about the key ideas about quantum physics. It is also giving us a comparison. Oh, good. So not bad for a local model running within a container, right? See, it gave this much information about quantum physics. Then remember, this is not a live model, it is just a model that is running within our container local setup. So this setup is very powerful because it is private, it is fully customizable, and it is free to use. No API keys, no subscriptions, just open source goodness. You can swap models, you can tweak the UI, or even deploy it for your own teams. It is completely under your control. But like you might have guessed, there are drawbacks to this one. So what are these drawbacks? The main thing is it doesn't have access to current information. So if I ask questions about recent events such as, say, who is the president? Who is the president of United States? See this one? It is giving the result based on its knowledge cutoff. Currently it is 2025, so the president of US is Donald Trump, but here it is giving us information based on its knowledge cutoff. I think it is around December 2022. So at that time the president of United States is Joe Biden. So that is why it is giving that response. So recent events it doesn't have any idea about, or even questions beyond the LLM's knowledge cutoff, like say who won the Nobel Peace Prize in 2024. Now if I ask this question, it will not be able to give an answer because 2024 is future for the knowledge that is there in our local model. So this is the drawback that we have with our experimental model that we have just created. So what do you think we should add to this local GPT application that we are building to make it more functional with the latest information? Share us your suggestions in the comment section below. In the next video, I'll show you a very easy way to make that work. Let's see what ideas you come up with. That's it folks. If you like this, smash that like button, subscribe for more, and grab the code from the description. Let me know in the comments what you would build with this one. See you in the next one. Bye bye. Thank you.